Here is example 5 from day 10. My PDF printed a little weird onto my Notability, so part of it is on the first page and the second. So a square is formed by joining the midpoints of alternate sides of a regular octagon. Find the area of the shaded region and round to the nearest hundredth. So I'm going to go through and label what I can. The first thing I can label, it says square. So now I know all of my sides are going to be congruent and all of my angles are going to be 90 degrees. It also said regular octagon, so now I know that every single side is going to be 8. And since every side is 8 and this was formed by connecting midpoints, I know that's going to be 4 and that's going to be 4, which means each of those sides is 4. Okay. So there's a few ways to go ahead and find the area of the shaded region. I'm going to show you the most efficient way. So find the area of the shaded region. If I look at that shaded regions, those are all trapezoids. So I'm really seeing just 4 identical trapezoids. So if I can multiply one trapezoid's area by 4, I have my shaded region. So just a friendly reminder, your area of a trapezoid is 1/2 times the sum of your bases times your height, which you can also write as your height times the quantity of your bases, the sum of your bases, divided by 2. Either one's totally fine. So if I look at my trapezoid, and I'm just going to focus on just one of them. I already have one of my bases as 8, because that's given to me. So now I'm going to focus in on finding all the other information. So I need to find my height, which could be there or here. And what's nice about that is I now know this piece is 8. So when I find those other 2 parts, I could just add them together to find that second base. So I need to figure out the height. In order to find that height, I really need to know what kind of triangle this is. What angles am I dealing with? So since this is a trapezoid, I know that the bases are parallel. And if I think about parallel, just to erase this real quick to show you, if I think about those parallel lines with the transversal being that side of 4, I know that this angle here is going to be an alternate interior angle to this angle. So if I could figure out what this angle is, I'm actually going to be able to figure out what type of triangle that is, and that's going to be my goal right now. So if I think about that whole angle, that is actually one of the angles of the octagon. So I know that that equation is 180. There's 8 sides, minus 2. And then since I am only trying to find one of them, I'm going to divide that by 8, which means that is 135 degrees. Well, if that's 135 and those 2 angles have to be supplementary, I know that this is a 45-degree angle, which now means I have an isosceles right triangle, 45, 45, 90. So if I think just about that triangle, which I'm going to redraw just for convenience here. So here's my height. I know that this is 4, and I know that these 2 are congruent angles. So my 4 is actually representing x root 2. So I'm going to divide by root 2, 4 root 2 over 2. Which means my x, which is also the height, is 2 root 2. And since that is a 45, 45, 90, so an isosceles, I know my height is 2 root 2, but also that other piece that of the base that I was missing is also 2 root 2. So now I can fill in that missing information, which I'm going to use this so that we could still see that picture. So I still have the 1/2 from before, 1/2 base 1, which was given to me, plus base 2, which if I look at that is 8 plus 2 root 2 plus 2 root 2, which is 4 root 2. Times my height, which was 2 root 2. So then, lots of simplifying. Ooh, yeah, just one trapezoid. Okay, we're good. So 1/2, 16 plus 4 root 2 times 2 root 2 equals 8 plus 2 root 2 times 2 root 2. And then I'm just going to distribute those. So 16 root 2, 2 root 2 times 2 root 2 is 4 times 2, which is 8. So I have that available for me. And that's only one trapezoid. So now I'm going to go ahead and, since there's 4 trapezoids, I'm going to do 4 times that quantity that we just found, which is 64 root 2 plus 32. It did say round to the nearest hundredth, so we actually were able to find the exact right there. If we round to the nearest hundredth, when I put that into my calculator, I get 122.51 units squared. And that's problem number 5.